In today's tutorial, we are going to do a segmentation along with tracking. So we are going to run a video, and this video contains several objects of the same class, apparently a dog, and we are going to do an instant segmentation and give a track ID for each of the dogs. Please subscribe and click here for more segmentation tutorials. Let's jump to the demo and it will be more clear. So let's run a short demo that explains what we are going to do today. First of all, this will be our code, a very short code, and we will do a step-by-step coding with explanation each of the Python commands here. Let's jump directly to the result. Let's open this folder. It's the same folder. This is will be part of the video description. I will leave a link for the code and for these videos. First of all, we will use this source video. Let's move it along. So you can see there are many dogs that running in the snow and moving, some to the right, some to the left. They are very similar, and basically we would like to do a segmentation and a tracking for each of the dogs, and also choose a number for each dog, a consistent number and a consistent color. So let's jump to the result. This one, output video, and now as you can see it's the same video. Each of the dogs get a number and a different color, a consistent number, a consistent color, and basically as you can see we are doing a segmentation. Look at the line around the dog. Each one of the dogs get a different color and a different number, tracking number. So that will be our tutorial today. So let's jump to the installation and the coding. Let's run a short brief about the installation. We will use YOLOv11, and in order to do that, first of all we will create a conda environment. This conda environment will be based on Python 3.11. If you are following my videos, it's basically the same concept. First of all, we are creating a conda environment, and then we will activate this environment. We can run it on an anaconda command prompt. After that, you should install a PyTorch. I am using PyTorch 2.5.0. I believe there are a newer version, but if you would like to get the same results, please choose the same one. It's more important to find what is your CUDA version. If you are using a GPU card, you can also run it on a CPU. If you are using a GPU card, first of all run this command in the Anaconda command prompt and you will discover what is your CUDA version. And after that, jump to the PyTorch website, and you can see for each of the versions there is a specific version for each CUDA version. For example, I'm using CUDA 12.4. You may find that this is the installation command for the PyTorch 2.5 for a CUDA 12.4. You can find version for 11.x, 10.x, and for a CPU for non-GPU users. And after that, you have to install two different Python libraries. The first one is Ultralytics that contain the YOLOv11. Please choose this specific version. I believe there are a newer one, but if you would like to get the same result, choose this specific version. And OpenCV, once again, choose the same version. And these both versions are work perfectly together. So let's continue the next step. So now we are ready to start coding. Let's create a new Python file. Let's name it segment and track.py. First we import OpenCV for handling the video input and output, and YOLO for Ultralytics segmentation. The next process, we will load the YOLOv11 large segmentation model. Please notice the L11L. And the next process, we will open our video file for reading. Let's copy the path for our source video file and paste it inside our video capture function. The next process, we will extract video properties. We would like to get the width, the height, and the frame per second. We will use these values later to save the processed video with the same dimensions and playback speed. We're extracting the width and the height and the frame per second. Now we will set up a video writer to save the output video. So we will store it in the same location. We will just update the name of the output file as output video. As you can see here, it's .mp4. Please replace it to avi.avi. I will change it later. We are sending the same parameters, the dimensions of the parameters, the width, the height, and the frame per second. You can see I need to fix it. It should be H, not G. H for height. Now we will start processing the video frame in a loop, and we will read the next frame from the video. And next we check if the video has ended or there is an error. If there is an error, we will break the loop. Now we will create an annotated object to draw the mask and the text. Next we will run the model in tracking mode for persistent, and we will grab the masks. Now if both boxes and mask are available in the results, that means that the prediction went well, so we will proceed to the next Python code. We will extract the mask and the tracking IDs from the results. We are converting those results to a list. It will be easier to loop through the results. And now we will loop through each mask and each track ID. We will use the zip to pair them together in the iteration. Now we will pick a unique color for each ID and annotate the mask and the label. So we will use the annotator.segBbox function, and we will send those parameters in order to display the consistent color and the track ID. This will make the output video easy to follow visually, even there are multiple objects in the screen. Now we will write the annotated frame to the output video. Next we will we will display the current result in a display video using the IMShow function. And the next code will be adding a key listener to break the loop when a Q button is pressed. And at last we will release the video writer and the capture object after the loop ends. You can see I have to fix it. The from should be .utils.plotting. So let's run the code. If you don't have yet the YOLOv11 on your local machine, the first step will be downloading the model weights. As you can see here, it's a very quick process, and after that we're expecting to see our video file. Great, as you can see, each of the classes and the object is being segmented, and also there is a trace, so the model knows and recognizes each of the dogs, gives him a number, and this number is on each of the frames. So thank you very much. I hope you enjoyed this tutorial. You are most welcome to subscribe my channels. More videos will be uploaded soon.